In a previous grade, you learned that prime numbers are whole numbers greater than 1 that have only two factors, 1 and the number itself. In other words, prime numbers are divisible only by the number 1 and itself. For example, 2, 3, 5, 7, and 11 are the first few prime numbers. The prime factorization of a number is all the prime numbers that, when multiplied together, result in the original number. One way numbers can be broken down to their prime factors is by using a factor tree. Let's do an example using the number 32. Think about all the factors that will give us a product of 32. We know that 8 times 4 is equal to 32. The arrows represent the branches of our tree. Since neither 8 nor 4 are prime, we must keep going. We create 2 more branches from each of these numbers and consider the factors for each. 4 times 2 gives us 8, and 2 times 2 gives us 4. We know that 2 is prime, but 4 is not. Therefore, we must keep going with the 4. We create 2 more branches from the 4 and consider its factors. 2 times 2 is 4. Since we are now left with only prime numbers, we are done factoring the number 32. We can say that the prime factorization of 32 is 2 times 2 times 2 times 2 times 2, or 2 to the 5th power. Substitution is one strategy that can be used to solve a system of equations and find the values of variables. Solving a system by substitution relies on being able to replace equivalent expressions with one another. If one of the given equations has been solved for one of its variables, then the expression to which that variable is equal can be substituted into the other equation for that variable. This new equation can be solved to find the value of one of the variables. Let's solve this system of equations by using substitution. In this system of equations, the top equation is already written so that one variable has been isolated on the left, in this case, y. This allows for substitution to occur. The y variable in the second equation can be replaced with the expression 3x minus 2. Which is equivalent to y. Now, this new equation can be solved for x. When we simplify, we see that x equals 2. Once the value for x has been determined, it can be substituted into the other equation to determine the value of y. In this example, if the value of x is substituted into the top equations, we find that the value of y is 4. So the solution to the system of equations is 2, 4. In your previous work, you have solved one variable inequalities. This section of exercises provides opportunity for practicing this and expressing the solution set in either interval notation or set notation, as well as on a number line. Both interval notation and set notation were a part of the work you did in Module 3 when describing increasing and decreasing intervals of a graph. They are two different notations that can also be used to show the solution set to an inequality. Solving one variable inequalities is much like solving one variable equations. It is important to remember how the inequality changes when operations of multiplication and division are performed with negative numbers. Let's do an example. Solve the inequality and write the solution set in both interval notation and set notation. Use the distributive property to get 6x minus 12 is greater than or equal to 12x plus 8, and then perform operations on both sides of the inequality to isolate the variable. In this example, the steps for solving require division by a negative number. which will reverse the inequality. The result is x is less than or equal to negative 20/6, which simplifies to negative 3 1/3. So the solution set will include all real numbers less than or equal to negative 3 1/3. This can be written in interval notation and set notation. In interval notation, we have the interval from negative infinity to negative 3 1/3, with the parentheses on the left and the square bracket on the right. Recall that the square bracket indicates that negative 3 1/3 is included in the solution set. In set notation, we have the set of x values in the real numbers where x is less than or equal to negative 3 1/3. The solution set can also be graphed on a number line by placing a solid dot on negative 3 1/3 and shading the number line with an arrow directed toward the values that are less than negative 3 1/3. Recall that a solid dot is used to indicate that negative 3 1/3 is included in the solution set.